Hi, welcome to Expertizer Academy. This is Giri, lecturer in physics. In this video, we discuss about the types of spectrum emission and then absorption spectrum, Fraunhofer lines. So look at here. Here we observe one graph. In x-axis there is wavelength. In y-axis there is a intensity of the light. Here for higher intensity, that range is 6000 K. So this is the surface of the sun. Next, so this one represents the carbon arc lamp. Next, this one represents the lamp filament maximum intensity. So this is the visible region, this is UV region, this is infrared region. So this is the structure to form the relation between the intensity and the wavelength graph. Next, the spectrums are divided into two types: emission spectra, absorption spectrum. First one is the emission spectrum. When the spectrum of self-luminous source is taken, we get emission spectrum. Spectrum of self-luminous source is taken. So that is emission spectrum. Each source has its own characteristic emission spectrum. Each source has its own characteristic emission spectrum. The emission spectrum can be divided into three types. The emission spectrum divided into three types. So first one, continuous emission spectra or continuous spectra. First one in emission spectra, that is continuous emission spectra or continuous spectra. So look at this. If the light from incandescent lamp or filament bulb is allowed to pass through prism, it splits into several colors. If the light from incandescent lamp is allowed to pass through prism, it splits into several colors. Thus, it consists of wavelengths containing all visible colors ranging from violet to red. So what happens here? The light is propagating from incandescent bulb to one prism. This light splits into 7 colors. It consists of wavelengths containing all visible colors ranging from violet to red. Example, spectrum obtained from carbon arc, incandescent solids, liquids gives continuous spectrum. Second in emission spectrum, that is line emission spectrum or line spectrum. Suppose light from hot gas is allowed to pass through prism, line spectrum is observed. Line spectra are also known as discontinuous spectra. The line spectra are sharp lines of different wavelengths or frequencies. Such spectra arise due to excited atoms of elements. These lines are characteristics of the element, which means it is different for different elements. Example, spectra of atomic hydrogen, helium. So what happened here with this? The hot gas is passing through prism. Here generates the line emission spectrum. So this spectrum is discontinuous spectrum, and here generates the sharp lines of different wavelengths and frequencies. Next, third one in this emission spectrum is band spectrum. So here different wavelengths of light generates the band spectrum. So these bands refers different frequency levels and different applications. Next, absorption spectra. The second spectrum is absorption spectrum, and this spectrum also converts or divides into three types. When light is allowed to pass through a medium or an absorption substance, then the spectrum obtained is known as absorption spectrum. The light is passing through a medium or an absorbing substance, then the spectrum obtained is known as absorption spectrum. It is the characteristics of absorption spectrum substance. Absorption spectrum is classified into three types. The absorption spectrum is classified into three types. So, first type in this absorption spectrum, that is continuous absorption spectrum. When the light is passing through a medium, it is dispersed by the prism. We get continuous absorption spectrum. When the light passing through a medium is dispersed by, there is a process is developed by the prism, that is dispersion. We get continuous absorption spectrum. For instance, when we pass white light through a blue glass plate, it absorbs everything except blue. For instance, when we pass white light through a blue glass plate, it absorbs everything except blue. This is an example of continuous absorption spectrum. Second one in this absorption spectrum, that is line absorption spectrum. When light from incandescent lamp is passed through cold gas, the spectrum obtained through the dispersion due to prism is line absorption spectrum. Similarly, if the line from carbon arc is made to pass through sodium vapor, a continuous spectrum of carbon arc with the two dark lines in the yellow region of sodium vapor is obtained. So look at here, this is the cold gas passing through the prism. So here we observe the absorption spectrum, line absorption spectrum. Third for absorption spectrum is band absorption spectrum. When the white light is passed through iodine vapor, dark bands on continuous bright background is obtained. This type of band is also obtained when white light is passed through dilute solution of lead or chlorophyll or through certain solutions of organic and inorganic compounds. So when white light is passed through iodine vapor, dark bands on continuous bright background is obtained. So these are the types of the absorption spectrum. So next, Fraunhofer lines. When the spectrum obtained from Sun is X-line, it consists of large number of dark lines, line absorption spectrum. These dark lines in the solar spectrum are known as Fraunhofer lines. The line absorption spectrum in the solar spectrum, it's nothing but Fraunhofer lines. The absorption spectrum for various materials are compared with the Fraunhofer lines in the solar spectrum, which helps in identifying elements present in the sun's atmosphere. So this one is absorbed in the sun's atmosphere. Fraunhofer lines is nothing but a line absorption spectrum by the solar spectrum. So this is the information about the types of spectrums. So thanks for watching this video. For more videos, visit www.expertiseracademy.com. Thank you.